The topic of this presentation is irrigation system maintenance and troubleshooting. Irrigation systems are an integral part of highly maintained turf. Supplemental applications of water provide the desired turf quality and playability during intermittent periods of moisture stress. Maintaining an irrigation system requires continual oversight and maintenance, no matter how technically advanced or expensive the system is. Some irrigation systems on golf courses can run into the multi-million-dollar range to purchase and install. Here we look at a few of the maintenance keys. An important key is a visual assessment on a regular basis of the system. Early detection of inadequacies or problems associated with the irrigation system can prevent moisture stress to the turf. For example, in this photograph, this baseball outfield is just starting to show early signs of wilt, depicted by the bluish-colored turf areas. The yellow areas are pointing to some of these wilting areas. If supplemental water applications are inadequate, moisture stress symptoms can progress rapidly. This photograph was taken a few days after the wilting became apparent. Irrigation systems, especially automatic ones, have evolved into very sophisticated systems. A fully automatic irrigation system requires periodic programming and maintenance. If water coverage is inadequate, check the controller station program time with the actual time the corresponding sprinkler is running. Maybe a discrepancy is occurring. Periodically checking the sprinklers from the control box can prevent problems from developing. Along with control box management, check the sprinkler pattern. One means of determining the distribution pattern for a sprinkler is called the can method. Not an elegant term, but very descriptive. Cans or containers are placed in a row, radiating out from the sprinkler. The sprinkler is then turned on for a given time period. The cans or cups can be collected and the depth of water in the containers measured with a ruler and the distribution pattern determined. For a properly functioning sprinkler, the amount of water decreases linearly as you move further from the sprinkler. The can method is also used to indicate the distribution uniformity for the irrigation system. In this case, the cans are placed within the area that receives water from multiple sprinkler heads to check uniformity of coverage. This also helps determine if adequate overlap of sprinkler heads is occurring. Improper water distribution can be caused by factors such as sprinkler head placement in regard to the soil or turf surface. The sprinkler head should be placed level and flush with the turf surface. A level sprinkler head produces desired water distribution pattern. The sprinkler should not be set so high that it can be damaged by equipment or cause injury to an athlete. The sprinkler head should be placed so that the water stream from the nozzle is not obstructed by the turf. In this photograph, the sprinkler head is located next to the water bottle. The only turf that is receiving water is within close proximity of the sprinkler head. The problem is the sprinkler head has settled to a depth where the water stream from the nozzle is obstructed by the turf surface. During regular use, sprinkler heads need to be periodically serviced and maintained. The nozzles should be checked for excessive wear or for any obstructions like small pebbles that may restrict water flow. In this case, the nozzle is open and fully operational. But in this case, a small pebble has become lodged in the nozzle. And yes, I did stage this picture by sticking a pebble in the nozzle, but you get the idea. Each sprinkler head likely has a screen or filter that can become broken or clogged with materials. In this case, the sprinkler screen is relatively clean and functional. The reddish color that has stained the sprinkler head is due to a high iron water source. In this case, the iron precipitate does not impact the operation of sprinkler head. However, where high salt water is used, precipitation of calcium and sodium may restrict or reduce sprinkler head efficiency. This photograph shows a screen at the base of the sprinkler head that has become clogged with dirt and soil particulates. Clogging of the screen disrupts or impedes water flow. Disruption of the water flow is shown here. The water stream is concentrated either close to the sprinkler head and then along the circumference. As a comparison, this picture shows the distribution pattern for the clogged sprinkler in the foreground, while in the background the distribution pattern of a properly working sprinkler is observed. A sign of a clogged sprinkler head may produce a pattern similar to this. The sprinkler is next to the water bottle. Notice the green grass close to the sprinkler and out along the circumference, but the turf is stressed in the middle of the pattern. Sprinkler heads and valves can leak over time. Sprinkler head or valve leaks can produce wet spots around the sprinkler head, making the soil or turf soft. Additionally, water flowing from leaks or breaks follows the slope of the land, producing green channels as shown here. Oftentimes, to compensate for inadequacies in the irrigation system design or for special problem sites, manual irrigation methods may be required to supplement the irrigation system during dry periods. Proper preventative irrigation maintenance practices will produce quality turf during periods of moisture stress. The most important key to proper irrigation maintenance is to be observant during moisture stress periods. This concludes this presentation on irrigation maintenance.